Okay, this is workbook 25.1. Sorry that I don't have a camera on. I'm in a place where it's not going to be a nice and easy way to see me. So this lesson is on using similarity to prove the mid-segment theorem. So you might be thinking, what's the mid-segment theorem? And it kind of describes itself mid-segment, like halfway through the segment. So basically you take a segment and halfway point is the midpoint, but then you connect those midpoints of the segments and it's called the mid-segment. And there are two things with this. So first of all, because it's a midpoint, it bisects each other. Then this one is parallel to that one. So ED is parallel to BC. So that's what it is. So this is a proof one. And so for the sake of time, I'm just going to cut to the proof. So it starts always with given. Then it talks about what those mid-segments mean. So this is equal to that. That one's congruent to that. That one's congruent to that. Meaning that their lengths are the same, equal. That's the definition of congruence. Then they talked about adding. These two add to that. These two add to that whole part. Then they substituted stuff in because we know that those two were proportional. And so then it's twice as much. So saying it's twice as much is actually a fancy way of saying that 2 is the ratio of corresponding sides. So you're looking for that ratio. So that's the ratio. A is congruent to itself. That is reflexive. If anything is congruent to itself, then we have to look for the only similarity statement in here. So there's only one similarity statement. Then right here, we have that similar triangles have proportional sides because BC is twice the length of DE. So that's proportional sides. And then the last part is just dividing that, and then you get the half. So that's what we're supposed to show. And then the next one, this one has a lot of words to it. So I just wanted to look at the things that are the same. It can be proven. It's the same on all of them. You can't just say because it looks like that, that doesn't make sense. If then corresponding sides are congruent, that's not true. They're similar, but they're not congruent. They're proportional, not congruent. So it is this one right here with similar angles are congruent. And just because they're similar doesn't mean they're parallel. So that is 25.1. And let me see if I can do 25.2 easily. And if I can, I will do it. Oh, yes. Okay, 25.2 is coming up. So it's using similarity to prove, this is again another proof one, medians are concurrent. So a median, what is a median is we start with the midpoint of the segments, but then you connect the midpoint of one side to the opposite angle. So midpoint to the opposite angle, midpoint to the opposite angle. And where they all connect is called the point of concurrency. And that point of concurrency, there's a name for that. It's called a centroid. So, excuse my cat. So there's a theorem that says all the medians of a triangle are concurrent, meaning that they connect at the same point, and that point is called the centroid. So we have proofs of them. So let's go do those. Hold on. What we are supposed to do for this question is to study the following triangle where segments BE and CD are mid-segments of a triangle and triangle ABC, and DE is the mid-segment drawn. So we are supposed to say which steps are required to prove that the medians are concurrent. So basically to prove that there's that, not orthocenter, what was it? Centroid. Okay, so we would need to do a couple of things. There's all but 2 of these will be checked. So we would want to prove, we can do a couple of things. So which steps are required? The only ones that are not required is this first one. So look for the one that says use the mid-segment theorem to prove that they're things. Don't mark that one. And then these two are very similar. And the one that you're supposed to use is the one that's 1/3, but not 1/2. So then mark everything else, but the one that says 1/2 and that one right there. Just telling you the answers because I can. Because it's not in order, and I think it would be very confusing to try to understand and explain it. And because you'd have to write out the whole proof, and I don't want to. Well, I could and I should, and that would be the responsible thing to do, but we didn't. Okay, and then the last part here. So Nikki is trying to prove that those triangles are similar. She determines that let's check, EF is parallel to AB, but she needs to provide a reason. Which reason proves that they're similar? And that would be because they're mid-segments. That would be the mid-segment theorem. Okay, that's 25.2. And then just so it's complete, we will do the checkpoint as well. All right, 100% always feels good. Psych, no checkpoint 25. It is exam 5, which I cannot help you with, so good luck.